Hello viewers. In this video, I'll go over the questions in exercise 1K, comprised of mixed sequences and series questions. In question 1, we are looking at an arithmetic sequence, first term being -8, and the sum of the first 20 terms to be 790. To find the common difference, we can use one of the formulas that we are given in the booklet. So either we have Sn equals n over 2 times u1 plus un, or n over 2 times 2 times u1 plus n minus 1d. So in this question, it seems like that we can use the second form because we are looking for d. And in addition, we don't actually know what the last term is. So I'm going to do 790 equals n is 20 because it says the first 20 terms sum. And first term is -8. So now we're actually just looking for d. So let's simplify what we can. This is 19d. I'm going to divide both sides by 10. So what I'm doing is I'm dividing these by 10. You could also expand out the 10 on the right hand side, but you just carry bigger numbers with you. Oops, which is not what I want to do. So go ahead and move -16 to the left and divide by 19. So that's our common difference. Let's label that part A. For B, we want to find the 28th term. So we actually have an term formula now because, well, let's write down what it is. Un is u1 plus n minus 1d, and we have all that information because we know that this is -8 plus n minus 1 times 5. So that means the 28th term will be -8 plus 27 times 5, which is 127. And hence, find the sum of the first 28 terms. So go ahead and just use the second form of the sum formula. This will be 28 minus 1 times 5. I'm going to simplify 28 divided by 2 to be 14. And this is 27 times 5, which is 135. You can just put all this in the calculator if this is not a paper 1 type of question, which will give us what? What will it give us? I'm horrible at this. 120 times 14 will be 1680 minus 14 will be 1666. And C, let's move C over here. How many terms does it take? How many terms does it take to reach 2000? So we want the sum to fall above 2000. When is the first term that gives us a total above that? So we can write down either the sum formula. This will be n minus 1 times 5. And then we can actually solve it algebraically, but then this might involve a quadratic sequence, which is not very nice to handle. So what I would suggest is for this type of question, you will want to use the GDC and find where is the sort of changing point. So what we do is we can type it in. We're going to replace n with x's. So we have x over 2 times 2 times -8 plus n minus 1 times 5. So what we're going to be doing is we're going to go to the table of values, and we're just going to scroll down until it goes above 2000. Usually the answer will be will be less than 40 terms, I would say, because here it's not to actually test you how fast you can scroll down the calculator, like what I'm doing now. So the breaking point, or the changing point, is from going from 30 to 31. So what you can write down is S30 is just below that sum. 2000, and 31 terms will just go above that. So your conclusion will be 31 terms. Okay. Question 2. Come on, why don't you like me? We have an arithmetic series. So we're given the sum of the 40 terms and the 40th term. Find the value of the first term and the common difference. So in this case, I will actually do as they say, because I know what the last term is, but I don't know what the first term is. So I can actually use the first form here and find out what the first term is first. If you try to use the second form, it will require the common difference, which you don't have, as well as the first term, which you also don't have. So you can't really use that form to your advantage. So here we have u1 plus 106. And then let's simplify this. Just like in the previous question, I'm going to divide by 20, which will be 95 on the left. So if I move 106 to the left, this will be minus 11. And then the common difference will be, you can use any formula you like now, but I will just stick with the UN formula. So U40 equals U1 plus 39 times the difference, and we will just substitute these here. Divided by 39, you get D equals 3. Okay, so we're given the sum of the infinite geometric series and the ratio. To find the first term, well, there's only one formula that we have, which is u1 over 1 minus r. So let's stick these in. To cancel out the denominator, just multiply by the denominator. So the first term is 16. Another infinite series question, but this time there's a little twist to it. The series is 3 times the first term. So what they're saying is S infinite is 3 times u1. So what you want to do is just write down the formula first, and then we can substitute this equation. So I'm going to write 3 times u1 on the left now, because it's 3 times u1. Now what do we do here? We know that we want to solve for the common ratio, but somehow we still have u1 involved. There's 2 things you can do. You can either divide both sides by u1 to actually get rid of that. That's actually what I recommend. Or you can first of all cancel the fraction by multiplying this. And you see how we can divide both sides by u1, right? So if I divide this by u1, I'll have 3 times 1 minus r equals 1. And then go ahead and just isolate r. Which is 2/3. No, come on, go the other way. Create 2 different infinite series that each have a sum of 8. Ooh, okay, let's see. So I know the controlling factors are going to be my first term and my common ratio. And given that this has to be 8, that means I want 2 numbers that are going to give to 8. I think easiest to control is r, because once I know what r is, I know what u1 is. The reason why I don't want to control u1 is because r can be outside of this restriction, right? So I might have like the first term to be 200, but then if it's 200, then r may be something that have to be outside of -1 and 1. So instead, I'm going to choose what r is. So let's say, suppose r equals 1/2. Then I would just have 8 equals u1 over 1 minus a half, which is just that a half. So multiply this by a half. So that is one sequence. So u1 equals 4, r equals 1/2. And then let's make another assumption. This time I'll just do -1/2. So as long as you pick anything that is within the restriction for r, it will work. So 8 equals u1 over 1 minus -1/2, which is this here. Again, we're going to multiply 3 halves to give us 12. So another infinite series with first term 12, show -1/2. Now, which question are we on? We should be on 6. We have a geometric sequence. Fourth term is 8. Sum of the first 10 terms is 2557.5. We want to find the 10th term. Okay. So what do we have here? Oh, sorry, this is the fourth term is 8 times the first term. So what do we have there? A mistake on my part. So what can we do here? With the sum, what we can actually rewrite this as is u4. Technically, it can be written as u1 plus 3d. Okay, n minus 1d. N minus 1 here is 4 minus 1, so it's just 3 times the difference. But in addition, we also know that this equals to, we also know that this is true. So if I just equate these two statements, I have u1 plus 3d equals 8u1. So therefore, 7u1 equals 3d. And I think this will be important later on. So let's take a look at the sum here. How can I express sum in terms of like the first term and the common difference? Well, we have n over 2 times 2 times u1 plus n minus 1d. Let's just simplify the right hand side a little bit. And we also know that this equals to 2557.5. So I can also, I guess I can expand this out. Actually, from experience, I know I didn't really have to do that. So what I'm actually dealing with is simultaneous equations. In this form here, because we can easily isolate one of the variables, we can just isolate what d is. So I would just go ahead and write d equals 7 over 3 u1. And then I'm going to take this and substitute this over there. So this gives us following. Seven over 3 u1. And that should simplify to 105. So now this whole equation is in terms of u1, so I can just solve for what u1 is. So if I add and divide, I should have the answer, which I don't. Why? The fourth term is 8 times the first term, and the sum of the first 10 terms is as follows. Find the 10th of the sequence. So I'm just looking for the first term and then generate this 10th term. But the problem is I don't even have the first term to be a nice number. Is it not nice? Is it not a nice number? Let me see. u1 plus 3d, u4, 7/3. Why is this such an odd number? Oh, I'm so sorry, guys. This would be true if the first word was arithmetic. So I guess I didn't read the question careful enough, so let's scratch that. And we need to redo all this. So sad. All right. Take two. u4 is 8 times the first term, doesn't change. Sum of the first 10 terms is 2557.5, doesn't change. So we want to also find what the 10th term is. That also doesn't change. But what changes is the first expression here. The fourth term can be written as u1r cubed. But at the same time, we know that this is 8 times u1, so therefore I can equate these. Oh, it makes the question much simpler. So therefore r cubed is just 8 so r is just the cube root of 8, which is 2. Then to find the 10th term, wait, I haven't used the sum yet because I don't know what the first term is. So sum of the first 10 terms in geometric is u1 times r to the power of n minus 1 over 2 minus 1. And we know that the sum is as follows. I don't really want to simplify this number. And it is just all for 1. So can I just do u1 equals 2557.5 divided by this quantity here. And please give me a nice number. Yes, exactly 2.5. So in order to go from the first term to the 10th term, we do u10 equals first term plus, oops, almost fell for that again. R to the power of 9 to get to the 10th term in geometric sequence. So 2.5 times to the power of 9 is 1280. Next up, so we have a company, a phone tree. I was just gonna be like phone tree, like is there like a phone up here or something? I don't know how do you draw a phone? It looks like a dynamite now. Okay, never mind. I think they're talking about these here, phone trees. Like, where does it connect to? Or maybe it's just at the back of the server. All right, sorry. To contact all employees in the case of emergency, each of the 5 presidents call 5 employees, which in turn, oh sorry, there's 2 part. Until they reach 2375. So again, I guess that diagram actually does help. There are 5 vice presidents, each one also call 5 other ones. And then of course it just keeps going. So we want to see how many rounds. So each one is 1 round, I guess. Each one is 1 branch to reach all 2,375. Now, I'm not sure that it will be an exact number, but by the way that this question is phrased, it seems like that's the case. So if not, then you will have to set this equality to be greater than 2,375, and then again pick the turning point in which it goes below that number to switching above. So here it will be, basically we want this. We want to do, first of all, we have the first round. It will be the 5 presidents, and then each one will call 5 more. So therefore it will be 5 times 5. And then the next round will be from the 5 times 5 people. They will also call 5 more. So we want to see how many of these terms does it take. So do you see how this is the common ratio? So therefore we want to find n such that u1 times r to the power of n minus 1 over r minus 1. Technically it should be exceeds, but here it says to reach all. So let's just see if this is a nice number. And if it's not, then we will have to actually do some approximation. So here I'm going to multiply this by the reciprocal. So I take these 2 terms and I'm just gonna flip it. So then on the right hand side would just be 5 to the power of n minus 1, which is 1900. And then let's add 1. So it seems like we have to do some approximations. So it does look like that we cannot reach exactly this many employees at a specific round. However, it will be a round where it will go over. So, well, let's just take what n is first of all. Here, to solve this, we can either use logarithm, which is follows. So n, if you take the log of both sides, this is n log 5. This is still log. And then we can divide out the ratio of the logs. Which is 4.69. So that means during like the 4.69th round, it will call up till the 1901st person. So therefore we round this up. We round up. So therefore it's going to be after 5 rounds. Another way is to set this equation. So we want to set this expression to be, actually I can just write this without splitting the fraction. You can write it as 5 times this is greater than 2375. So and then from the GDC, you have that here. And then going through the table of values, you will see that, oh, let me start at 0. See, it will make the gap, it will make the jump between 4 and 5. So here we have S4 to be 780. So after 4 rounds, that's how many employees it will reach. And then after the 5th round, it will have this many employees. So somewhere in between is where you will reach the 1900 employees. Well, yeah, 1900 and first employee here after the transformation. There's actually one more way to do this even quicker, but there are some caveats. But let me show you here. So for those who have been watching this video, you benefit. You want to go to solver, so go to math, and then it's actually right at the very bottom, but instead I'm going to hit up to get that. What numerical solver is, it's exactly solving this inequality. Well, it will solve this inequality in case of an equality. So basically it's solving the left hand side here. It's solving this part here. So we can just type in left hand side equals the right hand side. Oh, the bracket is in the wrong level. And then you click OK, which is denoted by the graph button. And then just guess what X is, doesn't matter. Actually, sometimes it does matter, and if it doesn't work, just change it to another number. So here I'm just gonna have it solve, just guess. And there we have 5.69, which is not what I want. It should be 4.69, so therefore I did something wrong. Oh, sorry. If I go back one step here, it's just the way I input this. It's on the wrong level. It should be -1. Okay. Before I had the -1 applied to the index rather than on its own level. So here's do it again. So this is where the 4.69 I got from dividing the log here on the bottom left. Okay. Two more to go. We have a sequence with positive terms only. So this implying that the ratio cannot be negative. It cannot go from positive to negative to positive to negative. And the sum of the first two terms are is 15. So u1 plus u2 equals 15. But I can also write this as u1 plus u1r. So I'm just going to write everything in terms of the first term and the common ratio. And the sum to infinity is 27. So these are our information. Find the value of the common ratio. So let's just start with an expression for the sum. We have u1 over 1 minus r. Let's just substitute what we have. Now the problem is we do not know what u1 is. However, we could actually substitute u1 as an expression. So if you choose this here, you will have two unknowns. I don't know what the second term is. So that's why we morph it into this case here. Now if I were to simplify this, I mean, if I were to isolate for u1, the technique here is to factorize. Okay, so I take away u1 from both the first two terms. And then now I'm just going to move 1 plus r to the right hand side by dividing. So now I can substitute this over here. And I will get 15 over 1 plus r, or divided by 1 minus r is 27. This might look intimidating at first. So let's cancel the fraction from the bottom by multiplying it. And guess what? We actually have another fraction here. So let me multiply that as well. And then the rest is also just manipulation. Now here, if you do FOIL, you will notice that this actually just simplifies to 1 minus r squared because this is a difference of squares. But let's just do FOIL. It will be 1 plus r minus r plus r squared. And you see that they actually cancel. This should be minus. So in order to isolate it, I will divide by 27 to both sides. And then I'm going to subtract this by 1. And then I'm going to divide this by negative. But let me simplify the right-hand side first. This will be 27 over 27. So this will be negative 12 over 27. And then I can, technically, I can simplify this further. If you have a calculator, then no matter, because you can just take the square root of it after negating it. But here, I would just divide this right-hand side by 3 each, top and bottom by 3. And then now I can cancel out the negative sign. And I'm going to take the square root of that. Normally, I would consider the negative as well, but because the question specifically say positive terms only, so I can just reject the negative. And just to be very specific, we reject negative as terms are positive. So that's a common ratio, yes. All that for the common ratio. Crazy, huh? And B, find the first term. Well, we got the hard part out of the way. Remember the sum formula is u1 over 1 minus r, and the sum is 27, right? 27. Sorry if I was scrolling up and down giving you a headache. And then we just do 1 minus 2/3, which is 1/3. So multiply this by 1/3. Get 9. And on to our final question. We have the first 3 terms of an infinite geometric sequence. Write down 2 expressions for r. So these are sort of typical style of questions that are on the harder side. So what you want to do first is to write the second term over the first term equals the third term over the second term. Always this is going to be the recipe. In other words, you take the middle divided by the first equals the last divided by the middle. Just to form a ratio expressions in terms of the ratio, because these are both, why is this keep raining? Because these are ratios. Okay, this is actually r, this is actually r as well too. And because r has to be the same, so they must be equal. So now we're gonna cross multiply. So we get, this is 36 equals m minus 1 bracket m plus 8. And for geometric, usually you end up with some sort of quadratic equation. So let's expand this out. Let's write this a bit nicer. And then we have m squared plus 7m minus 8. I'm also going to drag the 38 to the other side so that I set this equal to 0. Now you can either use quadratic formula, or for these kind of questions, usually they are factorizable. Okay, usually. So here I see that I can do 11 minus 4. So therefore m could be minus 11 or 4. So now we have two possible values for m. Basically, I should have labeled this as part B. Now C is, I'm going to put C here so that I can fit everything onto the same screen. One of these R values forms a geometric sequence. So where it is infinite. So what do they mean by that? Remember, we have a restriction for R. So first of all, what is R? We didn't write, oh, yeah, where is R? So this is only first part. This is part I. The second part is actually to find out what R is. Remember, one of these here represents R. Doesn't matter which one I substitute it in. So I will just take the one with, I guess, on the left-hand side. So if m equals minus 11, then R equals 6 over m minus 1, which is minus 1/2. If m equals 4, then R equals 6 over m minus 1, which is 2. So which one of this is between -1 and 1 is the first one. So therefore, we want m to be minus 11. So therefore, for C, this is the case where m equals 11, R equals -1/2. Oh, it says justify. So we justify R needs to be, oh, we can just say this. We can just say R has to be here. Therefore, R equals and not 2. Okay, just write down the inequality statement and then say that R equals to -1/2 is in this inequality. Or you can say, or you can just say the statement here and R equals -1/2 falls in this interval. Okay, just to make it really clear. But once you list out what the restriction is, it's pretty obvious that you know what you're doing. And for D, you also, oh, not D, I. Hence, calculate the sum to infinity. So go ahead and just use the formula. U1 over 1 minus R. But what is U1? Well, U1 is actually m minus 1. So remember, m is 11. So this is 10 over 1 minus -1/2, which is 10 over 3 over 2, which should be 20 over 3. Don't know why that's not the answer. Oh, sorry. M is -11. Okay, just rewrite this here. -12 over 3/2, which will be -24 over 3, which is -8. Okay. Hope you guys learned something, and I'll see you in my next video.